Students, this is the continuation audio and video for class 9th, subject physics, and is being submitted to you on 17th November 2020. In the first interactive session for this date, we learned about the basic process of total internal reflection and the concept of critical angle. Now further, today we will study the total internal reflection in a prism. Students, before starting this topic, you have to keep in mind that in case of normal incidence, that is, when incident ray falls at 90 degree on the surface of prism, the ray does not change its path. Now students, in case of normal incidence, if we are having a ray of light as shown and it is passing at 90 degree to the surface, then angle of incidence is not 90 degree, rather angle of incidence is 0 degree. The light is making an angle 90 degree with the surface, while the light is making 0 degree with the normal. In this case, the refracted ray do not bend away from the normal or towards the normal. The refracted ray moves in same direction without changing its path. So students, now first of all, we will study total internal reflection through an equilateral prism. Students, in our topic for today, it will be considered that critical angle of glass prism is equal to 42 degree. Now students, see figure number 1. A ray is incident normally on the prism. So if we say the ray P is incidenting on an equilateral prism, then when the light enters from air to the glass, it will not change its path. Why? Because it is a case of normal incidence such that the angles are as mentioned in figure number 1. Now students, see figure number 1 in case of prisms. So the first ray is striking at point P and this ray is normal incidence such that the ray will continue to move further in same direction, and if we complete the angles, then if angle P is 90 degree, and angle C internally is 60 degree, then this angle as shown in diagram is 30 degree. Here we will be using the sum of the angles in a triangle is 90 degree. So the sum of internal angles, we will be saying that the sum of internal angles of a triangle should be 180 degree. So this 90, 60, 30, the sum of all these three will be 180 degree. Now see what happens at point Q. At point Q, the ray is coming from denser and it has to go to rarer medium. So the light ray is an incident from denser, has to go to rarer. And if you see the angle made between the incident ray and the normal is shown dotted in figure 1. So the incident ray and the normal is having an angle of 60 degree. Students, normal means an angle of 90 degree. If some part of the angle is 30, then the remaining angle will be 90 degree minus 30 degree, that is 60 degree. So at point Q, angle of incidence is 60 degree, which is greater than critical angle assumed to be 42 degree. Moreover, the light is going from denser to rarer medium. So both the conditions of TIR is satisfied at this place. What does it mean? It means that at point Q, the light will not get refracted in air. Rather, the light will now get totally reflected in the same medium such that angle of refraction is 0 degree, while angle of reflection is 60 degree. Students, angle of incidence and angle of reflection is always equal. Hence, if angle of incidence is 60 degree, then angle of reflection will also be 60 degree as shown in figure number 1. Now students, if angle of reflection is 60 degree, then normal is making 90 degree with the prism surface. Hence, the remaining angle will be 30 degree. If you see triangle QRB in figure number 1, one of the angle is 30, one angle is 60 since it is an equilateral prism. So if we take third angle as X, we can find X to be 90 degree. Now see what happens at point R. At point R, the ray of light is again coming from denser to rarer medium. So first condition of TIR is satisfied, while here the angle of incidence is not 90. The light is normally incident. So the angle of incidence is 0 degree, which is less than critical angle. Since critical angle is 42 degree for glass. So at point R, both the conditions of TIR is not satisfied. So your light will be refracted in the other medium and angle of refraction will also be 0 degree here, such that the light passes undeviated from the surface AB of the prism. So students, in figure 1, a light is incident normally at point P on the glass prism and thus it reaches at point Q without getting deviated. In case of point Q, our angle of incidence is greater than critical angle and the light is going from denser to rarer medium. So the case of TIR will take place, and at point R, if we complete all the angles of the triangle, then angle QRB comes out to be 90 degree. While in this case, angle of incidence will be 0 degree, as at point R, normal incidence is occurring. The angle of incidence is less than critical angle. Thus, light is refracted in air without changing its path at point R in figure number 1. Now students, let us do TIR and refraction of light through a 30 degree, 90 degree and 60 degree prism. That means the angles of the prism is 90, 60 and 30 as shown in figure number 2 drawn on page number 6 of the notes sent to you on 17th November 2020. Now students, the light is incident normally from point P and thus it will pass without getting deviated. On completion of angles, if one angle is 60 degree at the vertex, 90 degree at point P, then the third angle will be 30 degree according to the angle sum property of the triangle. Now students, see point Q on the surface AC of the prism. At point Q, let us draw the normal as shown in figure in a dotted manner. So, the angle made between the prism surface and normal is 90 degree. This is 90 degree. Some part of angle is 30 degree. Thus, the angle of incidence is 60 degree at point Q. Moreover, the light is going from denser medium to rarer medium. So both the conditions are satisfied at point Q. Thus, the ray, instead of going in the other medium, it bends back in the glass prism, and the ray QR is totally internally reflected ray, such that angle of reflection will be equal to angle of incidence, and angle of reflection will be also 60 degree, such that the remaining part of the normal will be having an angle of 30 degree. Now students, this internally reflected ray QR, when reaches at point R, then again the light has to travel from denser to rarer medium. But here the angle of incidence is 30 degree, which is less than 42 degree, due to which the ray at point R is not internally reflected. Rather, the ray passes to the other medium and the process of refraction occurs. Now students, here what happens? The TIR occurs at point Q, where angle of incidence is 60 degree, and the light goes from denser to rarer medium. The light bends in the same medium such that angle of reflection is 60 degree, as angle I, angle of incidence, is equal to angle of reflection, and the light reaches at point R, where angle of incidence now is 30 degree, which is less than critical angle, that is 42 degree. So no TIR occurs, but only refraction occurs at point R, where light is going from denser to rarer medium, and thus the light will bend away from the normal at point R. So now students, based on today's learning, I am giving you two different cases for a right angle prism. You all are required to complete the ray diagram in your physics notebook, and first you observe figure number 3. In figure number 3, the incident ray is above the half of the length of AC. So in figure number 3, the light is incident normally, but it is above the half of length AC. While in figure number 4, the incident ray is below the half of line AC. Now you may pause this video audio and complete the ray diagram, and later resume the session to check your ray diagrams. Now students, let us check the answers done about the ray diagrams given to you. So if we complete the ray diagram of figure number 3, in this case, the light ray was incident from point P above the half of surface of prism AC. Now, since it is a case of normal incidence, thus the light will not bend, rather it will continue to move in same path even if it is changing its medium from air to glass. So the light reaches at point Q, and from point Q, if we draw a normal to point Q, which is shown dotted in the diagram. So normal means an angle of 90 degree. So if the complete angle is 90 degree, so first of all, see on the surface of AC, the angle is, the light is entering normally. So if one angle is 30 degree at point A, which is given in the question, that means the remaining angle will be 60 degree. So the remaining angle is shown to be 60 degree. Now let us draw a normal at point Q such that the total angle of normal with the surface of prism is 90 degree. If some part of 90 is already 60 degree, then the remaining part will be having an angle of 30 degree. Now students, this 30 degree will serve as angle of incidence for point Q. Since at point Q, the angle made between the incident ray and the normal is 30 degree. Thus, we can say that at Q, angle of incidence is 30 degree, which is less than critical angle of the glass prism, that is 42 degree. So at point Q, the light will not get reflected, rather it will move from denser to rarer medium in such a manner that the light ray bends away from the normal. Hence, in this case A, no TIR will take place. So now in case B, when the ray of light is normally incident at point P below the half of AC surface of the prism, then the light is normally incidence and one of the angle of the vertex at point C is 60 degree given to us. Then the remaining angle at point Q will be 30 degree. So if we draw the normal at point Q, the ray is incident from P to Q. At point Q, the ray has to go from denser to rarer medium, and the angle made by the normal and the incident ray is 60 degree, which is greater than 42 degree. Hence, the ray of light will bend in same medium at point R, and the angle of reflection will also be 60 degree. Now students, if we draw a normal at point R such that the two normals intersect each other and makes an angle of 90 degree, then in the triangle the angles will be 60, 90, and the third angle will be 30 degree. So at point R, angle of incidence is 30 degree, which is less than critical angle, which means that the light will not return back in the same medium. Rather, at point R, the light will refract and bend away from the normal. So students, with this, I will end this interactive session. You all are advised to practice the ray diagrams and try question number 17 and 22 in your physics notebook. Thank you, children.